Welcome to This Explainer. Today, we're diving into a complete, highly visual journey through the AI 900 curriculum. If you've ever wondered how to go from the absolute core concepts of artificial intelligence all the way to deploying safe, modern applications in the Azure cloud, well, you are in exactly the right place. We're going to demystify the jargon, look under the hood of machine learning, and map out the entire landscape right here together.
All right, let's take a look at our roadmap for today. We've got 6 main stops: the layers of AI, inside Azure machine learning, ready-to-use cognitive services, understanding generative AI, connecting via Foundry endpoints, and finally, principles of responsible AI.
Okay, Section 1, the layers of AI. Let's start by understanding the basics.
To really wrap your head around this technology, it helps to think of it kind of like a set of Russian matryoshka dolls. You know, where each layer is nested inside a broader one. Let's look at that outermost doll first, artificial intelligence. Basically, AI is just the big umbrella term for software that performs jobs that mimic human behavior and capabilities. So whether it's a chessbot trying to anticipate your next move or your smart speaker parsing your voice commands, it's really just the broad outcome of a machine acting in a human-like way.
Now let's pop open that outer layer to reveal the next doll hiding inside: machine learning. This is really the engine of a modern AI system. You see, in standard software, a developer writes explicit if-then rules, right? Like, if an email contains the word free, mark as spam. Well, machine learning doesn't do that. Instead, it uses statistics to learn from massive amounts of data. It finds patterns and actually gets better at a task all on its own, without anyone explicitly programming every single edge case into it.
And if we peel back one more layer, we find the deepest, most complex doll of them all: deep learning. This relies on artificial neural networks, which are actually inspired by the human brain, utilizing 3 or more hidden layers of nodes to solve incredibly complex problems. Because these networks are insanely dense, like teaching a self-driving car to recognize a stop sign in an absolute downpour, they require massive computational power. That's exactly why they rely so heavily on the parallel processing power of GPUs to do the heavy lifting.
So when we look at classical machine learning, it basically splits into 2 main camps. On one side, we have supervised learning. Here, we're feeding the model human-labeled data, what we call ground truth, so it can learn to make specific predictions. Think of predicting house prices based on a spreadsheet of known past sales. On the flip side is unsupervised learning. The data here has absolutely no labels. The machine is essentially turned loose to find hidden structures and clusters totally on its own. It's like having a group of companies' customers by purchasing behavior without giving it any prior categories to work with.
Moving on to Section 2, inside Azure machine learning. Welcome to the Builder's Workspace.
To actually build these models, we rely on a machine learning pipeline. Honestly, just think of this as an assembly line. Step 1 is data labeling, where we establish that ground truth we just talked about. Step 2 is feature engineering. This essentially translates messy, raw data into clean, numerical formats that the machine can actually digest. Then Step 3 is training, where the model iteratively learns from that data. And finally, Step 4 is serving. This is where we deploy the model out into the real world so your app can send requests and get instant predictions right back.
Now, if managing that entire pipeline sounds like weeks of manual, tedious work, well, it used to be. But enter Azure Automated Machine Learning, or AutoML. This tool is a total game changer because it massively accelerates the whole process. It automatically tests dozens of different algorithms for you, applies crucial data guardrail checks, and then recommends the absolute best candidate model. And here's the best part: it provides model explainability, or MXL, so you aren't just dealing with some mysterious black box. You can see exactly which data features influence the winning model's decisions.
All right, Section 3, ready-to-use cognitive services. Let's look at some pre-built AI APIs.
The great thing is you don't always have to build custom pipelines from scratch. Azure offers this huge catalog of cognitive services. Basically, these are pre-trained models grouped into vision, speech, language, and decision categories. Honestly, these are a developer's best friend. Need your finance app to read text from a crumpled scanned receipt? Just drop in the Form Recognizer API. Want to instantly gauge if a flood of customer feedback is angry or happy? Drop in text analytics. It's amazing because you can inject world-class intelligence directly into your software in minutes, totally bypassing the need to be a data scientist.
And when you start stacking several of those cognitive services together, you unlock a really powerful capability called knowledge mining. This happens in 3 steps: ingest, enrich, Explore. Imagine ingesting massive piles of unstructured, messy enterprise documents. We're talking like 10,000 PDFs. You then enrich them by running them through multiple APIs to extract key phrases, translate languages, or even recognize images. Finally, it outputs an enriched index that you can instantly explore. It literally turns unstructured chaos into highly searchable knowledge.
Next up is Section 4, Understanding Generative AI. We're going beyond classification here. This brings us to the newest and, let's be real, probably the most hyped addition to the AI landscape right now. Generative AI is fundamentally different from what we've covered so far. Regular AI focuses on analyzing existing data to make a decision, like classifying an image or predicting next quarter's sales numbers. But generative AI steps beyond classification and straight into the realm of creation. It uses its training data to output entirely novel creations, whether that's generating a stunning landscape image, writing a highly detailed essay, or even coding a whole website from scratch. So the engine behind tools like ChatGPT isn't magic, even if it feels like it. It's actually a large language model, or LLM. Under the hood, these models are trained on massive text datasets and use complex transformer architectures to understand context. All they're really doing is calculating and continually predicting the next most likely word in the sequence, over and over again. Think of it like a vastly supercharged version of the predictive text autocomplete on your smartphone, rapidly stringing together probabilities to generate a response that sounds completely coherent.
Which leads us to Section 5, Connecting via Foundry Endpoints. Time to wire your apps together.
So, we've got all these amazing pre-built and custom models sitting in the cloud. But that leaves us with a pretty critical architectural question. How do client applications actually talk to these cloud-based models securely and reliably? Well, the answer lies in APIs.
Here's how that communication actually happens on a technical level. Whether you're leveraging an LLM or a custom vision model, your client application communicates securely with Azure over the internet using Microsoft Foundry REST API endpoints. An endpoint is essentially just a secure, unique HTTP address. Your app wraps your prompt into a lightweight JSON package, sends it over using a secure authentication key, and then the Azure model processes it. It then returns its generated response back in JSON format, which your application can then seamlessly display to the user. And finally, Section 6, Principles of Responsible AI. Let's talk about implementing ethical guardrails.
Because, look, deploying AI securely isn't just about API keys and cloud infrastructure. It's absolutely crucial that we build with ethical guardrails in place. Microsoft defined 6 core principles of responsible AI that you really need to know. First, fairness, ensuring models don't discriminate based on historical biases. Next is reliability and safety, which means rigorously testing to prevent any physical or digital harm. Then we have privacy and security, locking down user data. Inclusiveness ensures the tech empowers everyone, including those with disabilities. Transparency means users actually understand how the AI is making its decisions. And finally, accountability, maintaining that humans must always take ultimate responsibility for an AI's actions.
In practical terms, applying those ethical principles means actively implementing strict content filters and guardrails in production environments. It means engineering systems that purposefully intercept and block the generation of harmful, illegal, or offensive content before it ever reaches a user's screen. And in the physical world, think autonomous robotics, it means utilizing strict probability thresholds. If the AI isn't absolutely confident in its assessment, the guardrails ensure it safely does nothing, rather than taking a potentially catastrophic action.
I want to leave you with a final, somewhat provocative thought. As our capabilities continue to expand from simple data classification all the way into highly autonomous content generation, how will you ensure the solutions you build remain transparent and accountable to the human beings relying on them? By applying the Azure tools and the ethical frameworks we've explored today, you have the power to build applications that aren't just smarter, but fundamentally safer. Thanks so much for joining me on this explainer, and keep learning.